All right. So good morning, everyone. Today, it is our lab section, so we're gonna have 2 hours to work on. So the first hour is gonna be myself going through, finishing with you all the exercise on data wrangling, and then I'm gonna have an assignment for you for that. And then on the second hour, Dr. Lacerda is gonna come in and finish with the slides that you all started with her. And I believe she's also going to have like a take-home assignment for you. So lots of things going on today. Okay, so you probably, I guess you're getting used to it now, but I really would like for you to, if you don't have yet, go ahead and open the folder for the course. So the main folder for the course that you have on your computer, you should be seeing that 01 data wrangling folder in there. You want to open it. And then again, we're going to launch this project that we've been working with for the data wrangling exercise. So you can just go ahead and double click on that .rproj icon. That will basically launch an RStudio session that is focused on this project that we've been working with, right? And again, I just wanted to make this very clear again. If you, for some reason, is having issues with the project, with the importing data, do let me know, because this concept of setting up the project and the folders and subfolders correctly is going to be very important for this exercise, but also for future ones. And so getting that concept right is important. And I want to make sure everyone is able to. Okay, so if you open your RStudio project, you should be seeing something similar to what I am seeing here, where, so again, how do you know that that everything is set up correctly? You should be seeing the 01 data wrangling project name on the top right. If it says preview none, you're not doing this right. You're not in this project, and the relative paths would not work. But if I do assume that all of you already figured this out, since we've been working with this for the third class now. If you didn't, let me know. Your environment may not be empty. Hopefully it is empty. If it is not empty, I want to invite you to click on that broom symbol there to clear your environment. This comes back to that option of starting fresh every time you open R. You don't want to be saving your variables from one day to the next, because things can change and that can create some issues as we're developing code over time. Here, you should be seeing on the bottom right your files tab. If it's not on the files tab, you can just change to it and comes to the files tab. You see, the main view of the project. You can click on that blue wire button to bring you to the main folder of the project if you're not seeing that. And then if you for some reason don't have your script popped up like I have here, you would basically go on code and just click on it, and that would bring it up. So we can restart today from where we left off last time. Okay, so this was, just introducing again what we were doing. Again, last time we stopped at the SOIK8 range. This is where we stopped. And again, because we want to finish this exercise, we want to rerun everything up until this point, or not everything, but some of the things that we did. So if I just go back up to the setup, we do want to, load all the packages. Remember, we do that every time that we start a new R session. We do want to run the chunk with the data. And if you have the view windows popping up here, you can just close them. We do not need to run the glimpse because that's not saving to anything. Summary, we don't have to run at this point. You do want to run the SOIK1. We can skip SOIK2 since that kind of stopped there. You want to run SOIK3, which was the mutate. You can just close that window. We do want to run SOIK4, which was creating the wraps. You also want to run SOIK5, which was just changing the shape of the column from a wide to a long format. And also want to run SOIK6, which is where we separated to have only the location information in one column. You also want to go ahead and run the select, so SOIK7, so we only keep the columns that we want to move forward, right? And then also go ahead and run soik8, which is the one that we're just arranging or sorting the data based on location.
So whenever you do this and you go to open it, do you automatically need to just go ahead and run from where you started back down?
So something that you can do, and we could have done here, although I'm not sure how the view functions would have changed, is so let's say if I know that I'm starting here on soik9 and I want to run everything that's above it, every chunk has this button here, which is basically run everything above. So you could have clicked on that, and that sometimes can be faster. I think that if we do here, it's gonna run until here. So let me just show that quickly. So you don't have to do this if you don't want to. I'm just gonna clear my environment. And I want to click, so come to the chunk that we're going to work next and run everything that comes above it, which is using this button here. Yeah, that basically does it all for us. And if you want to make sure that everything already ran and you didn't have any issues, I normally open the console here and I see, like, just quickly browse to see if I have any issues. I don't see any issues. And so, yeah, we could have also done that.
Yeah, that's what I was wondering, because I don't remember like soik3 or something like that, and I had to start from the top and come back down. I didn't know if there was an easier way to do that, which
Yeah. Yeah, no, that's a good question. And I guess I was just not showing you that yet, just because, some of you may have, I know that perhaps you're moving things around. So let's say a very easy problem that could have happened here. Let's say you don't have to repeat this. I just want to show you. So if for some reason, right, so if I'm going to clear again my environment, and I just want to have here soik1 before I create it, right? Meaning that if I run everything up until this point, so stopping right here, I don't have soik1 in my environment yet. But if for some reason my code says this and I run this, I got an error because it doesn't exist yet, right? So at first I have to create it and then print it.
Yeah, that was the issue I had whenever I went to go do it before it was
right.
hot.
Yeah, so if that happens, and if you come to, let's say, where we just did the run all above and we did this here, it would not do what we expected, because it would have stopped at that chunk that had an error, but you may not realize where the error happened, right? So we basically have to go back and see, like, where did you get the error? Which would be like, you would see that red right there and saying error. But if you do chunk by chunk, at least if there is an error, it's right there and you can fix it. If you hit the run all above, then it's a little bit more mysterious to see where the error happened. But if your code is clean and you did everything in the same order as I was showing in class, then it should work to just run all above, which I'm going to do here again, just to speed up. So we'll come here and then just run all above. It pops up all the view functions. I just close them. Okay, so I want to show you a very powerful combo here for data wrangling that, if anyone has ever used pivot tables in Excel, this is one of the things that you can attain with pivot tables, is like getting summaries, right? So let's say if for some reason I wanted to know the average of the potassium concentration on soybean trifoliates by location, or maybe by rep, or by some variable that I have in my data set. How do I do that? How do I extract that mean from these columns here? So the first thing to do that is we have to use a function called group by, and I just want to show you here. You can come on soik9, use the assignment symbol, and then call the function group underscore underscore by. Remember, every time we're using these functions, the first argument we give it is the data frame coming in, which is what we just had above. So soik underscore 8. Just so refresh your minds, this is what soik8 looks like. So we only have location, rep, potassium rate, and potassium concentration, right? So let's say we wanted to get the mean potassium concentration for each location. So if we have 4 locations, we're going to have 4 values out of this. So we basically give the data set and we say which column we want to summarize by. So this would be location, right? Okay, so you can go ahead and run this. And you can go ahead and print soy K9, which is already left you there for you to print. Okay, so let's first inspect soy K8, right? So soy K8 has 64 rows and 4 columns. If we're doing a summary over location, we're gonna have less than 64 rows, right? That has to happen. However, that's not what happened yet, right? So we still have 64 rows, but there's something new that popped up here that I just want to call your attention to, which is saying that we have groups based on location. So we have 4 groups. Okay, that's, extra information. It wasn't there for soy K8 when we printed soy K8. So what's going on here? If we get the class, so remember, the class function helps us understand how R is interpreting a given object. So this object is a data frame. So let's just get the class of soy K8. So here it says that is a table, data frame, table, or a data dot frame. So it has 3 different types of classes, but they're all related to data frames, right? Now let's try the same for soy K9 and see what it looks like. So you can see that there is a little bit of a difference here. So soy K9 now has this extra class type, which is called group DF, which is basically just telling us that the data set has been grouped by location in this case, but nothing has happened yet because we have not asked for it to do anything with those groups yet. So behind the scenes, soy K9 is already a group DF that's ready to be summarized by something that we tell it to summarize over, but it hasn't been summarized yet. So that's why soy K9 still has the same number of columns as soy K8. So soy K9 is a group data set, soy K8 is not. So how do we actually get the mean here, right, over locations, which is the group that we just created? So if you come next to the soy K10 step here, you can use the assignment symbol, and we're going to use the function summarize like that. Again, the first thing that comes in is a data frame. So that's going to be soy K_9, the one that we just grouped above. You add a comma, hit return just to break the code. And now we have to give the name of the column where we want the means to go under. I want to call that mean K_PCT. So it's going to be the mean potassium concentration percentage. We say equal, and then we give it a function that if I want the mean, the function has to be the mean, right? And then inside of this function here, I need to give which column I want the mean of. So it's grouped by location, but so what? What am I get by location? I really want to get the mean of KPCT, right? So I just say mean KPCT. So if we run this now and we print it, now we actually did what we wanted it to do, right? So now we have 4 rows only. It only kept location, which was the grouping variable, and what we asked it to do or to create, so the mean KPCT column that now has just the average over each one of the locations. So we end up with 4 rows because we have 4 locations. Also notice now that soy K10 is not a group data frame anymore. It doesn't have the groups here when we print it. And so that's how we know. And so I just wanted to show you this here to make the point that this is a combo. So you have to use group by first to set what you want to average or you want to summarize over. And then following that, we use a summarize to then say what type of summary you're trying to extract. Here, we use the mean. This could have been, so other functions that R has that could have been here would be like min, like min for minimum. It could be max for maximum. It could be median. It could be standard deviation, SD. So there's really a whole lot of descriptive statistics that we can do here. And of course, I mean, the name that we gave here is arbitrary. It could have been whatever name. But of course, if you're doing a standard deviation, you want to express that on your code, right? I mean, you can just keep the mean KPCT. That's what I wanted you to do. But I also wanted to show you how you would do this. And well, something just going a little bit off script here, but if we were to, let's say if I did wanted to know the standard deviation, right? I could very easily just add a comma here and say like SD K underscore PCT or whatever name really is just, that's arbitrary, but then the function and then K PCT. So if I did this, the output would actually be two columns where one is the mean, the other is the standard deviation. So you can easily plug in multiple summary statistics at the summarized level, and at the group by level, you can really plug in different variables that you want to summarize over, right? So this is where you define what's being done over. This is what you define what you're extracting from that grouping. Yes.
So say you don't like the name of your column, and you want to go back and change it.
Mhm.
Can you just change the name and then just rerun the same like line of code and it just like goes over what you already have? Or is it
So-
gonna create another?
You mean like if I call the output of this the same as that? Is that what you're saying? Like what
No,
would
I'm just
happen?
saying, like, if you change the name, if you change like a name of it, like say you want to put like a space in between me and KPCQ or something like that,
Okay,
like for the name of the column.
right. So as long, I mean, you can do that on your side. I would recommend at least for the exercises to keep following what I'm doing,
Yeah,
so
I'm
you
just,
follow.
I'm just saying, like,
But yeah,
if you went back and decided you wanted
Oh,
to
yeah.
change the name later on, it's not gonna change, it won't hurt.
no.
Just rerun the program or the
So
line of code.
you can definitely, like the names that we give, especially like when on the mutates and on here, it's really like arbitrary names, right?
Yeah.
Right, so you can definitely change them. The only thing is like if you change here, let's say if you do mean underscore KBCT, you have to make sure that that same name comes after as well when you're
Yeah.
calling that column, right? Yeah, but definitely, yeah, the name is just, is really, like I just try to be as short as possible and as clear as possible with the names, right? Because these column names are things that we're going to be calling later on ggplots or models or things like that. So you don't want like a very long name. And I would definitely discourage white space. So if you did white space here, it would not work. Like that would throw an error. If you really, for some reason, wanted white space, you would have to do something like this. I think that would work, but I was still discouraged because then every time that you call this column, you have to include the little things, the apostrophes or whatever. So it's not very efficient from a programming standpoint. But yeah, the name is really up to whoever's writing it. Okay, so I really just needed you to just delete. I mean, I'm going to delete on my side just so you can continue, but I think you all got the idea of how we can do that, right? Okay, so now I want to show you a very, very cool concept that in R is really easy to do and very useful. We're going to be using this a lot throughout the course. In other languages, if you're working with Python, it has sometimes a similar way of doing this, but it's not as intuitive and straightforward. So if you notice, look at how many steps we took here. So we clean names, the filter, we didn't really continue to use it, but let's say that you did for some reason. So we clean names, filter, mutate, case when, I mean, we had 10 steps to go from raw data to the final version that we wanted, right? And what we had to do here was, so starting with soy K1, and then we did something, we saved that to an object, and that new object was the input of the next function and so on, right? We were just like feeding from what we were building throughout. I mean, can you do that? Yeah, you can do that. But it's not, I think it just creates more room for error because you're creating multiple intermediate products that you really don't care about. You just care about the final product that, let's say in this case, if your goal was to get the mean, this is your final product, right? That's what you really care about. You don't care about soy K1 through 9, you just want soy K10.
So can you essentially skip a lot of those steps?
We're going to not necessarily skip, but combine them. Yeah, so that's what we're going to see next. So in R, there is this concept of using a pipe. I don't know if anyone ever heard about this concept, but the pipe is basically just like this symbol here. So percent greater than percent. And what the pipe does is basically takes whatever is on its left and feeds that into the next function as the first argument. So basically takes X and feeds that into a function Y as the first argument. Is a really nice way to combine multiple things that happen in sequence without having to create intermediate steps. And that's what I want to show you here, how we can do that. So I want to call this object soyk underscore W. So we use the assign symbol. The starting data set, if you remember, was called soyk, right? So that's what we did. And the first thing we did with it was to do the clean names. So what we would do here is we would add a pipe. So doing the percent greater than percent. It's convention to hit return just to break your code and make it easier to read. And then right now is where you kind of have to have your outline showing the chunk names, because then you can easily do this. I just want you to come first to clean names, just copy the clean names part of it. So leave the soyk1 behind, just the clean names, and then come back to the chunk that's called piping it all together and just paste clean names right there. Now, one thing I want you to notice is because the pipe is already taking whatever is on its left and feeding as the input of whatever it's on its right, we do not need to have soyk inside clean names here because the pipe is doing that for us. Okay? So if we run this and print it, this is basically what soyk1 was, right? At this stage, at least. But now the goal is to combine all of the functions that we use up until this point using the pipe concept. So if you were able to do this, then the next step would be to add the pipe after clean names, hit return again, and we're going to skip soyk2 because we didn't continue with that in our workflow when we did one by one. So go to soyk3, and again, you can just copy everything starting at the mutate. So leave soyk3 assignment symbol behind, just the mutate part. Go down to the piping it all together chunk and paste it. Now, again, you do not have, because it's in a pipe workflow, you do not have to give it the data set because it's assuming that whatever is coming before that pipe is the incoming data set. So you can just delete soyk1 at this stage. So the same, I'm just going to continue doing this as far as adding a pipe at the end, hitting return. Now we're going to go to so after mutate, we did the case when, so soyk4. I just copy everything that's there. Go back to the piping it all together chunk, paste it, and don't forget to remove that data set that we did individually mention, but now we don't need that. Go back or add another pipe, hit return. So after the case when, we went to pivot longer, so we can go to pivot longer. So that's soyk5, copy.
Dr. Bassos.
Yes.
So what you're saying is after every function we add in, we just add the pipe symbol and then copy another one in?
Yeah, so what we're doing is adding the pipe, going up to the chunk that is doing what we wanted to do, copy that, paste below here, but also do not forget to delete the data set coming in when you paste over here, right? Because again, that portion is being done by the pipe, right? The pipe is taking whatever is on its left and feeding that as the incoming data set of the function that is on its right. So we have to delete that. Yeah. Does that make sense?
I think so. I don't. I'm a little behind you. I think I fell behind a little bit when you started with this, the pipe stuff.
Yeah. So again, like if you well, let's look here. You know, so we're starting with the soyk, right? And soyk. So what this function here is doing is basically the same as. So I'm going to type here, but no, you don't have to do it on your side. But if you think about it, this here is exactly the same as clean names soyk, right? So what the pipe is doing is basically taking what is on its left and giving that as the first argument to the function on its right. And the first argument is normally the data set, so that's how it works nicely. However, If I am using the pipe, I don't have to say soy K here again, which is what we had on the chunk, individual chunk on the clean name.
Would it mess it up or is it just pointless?
Sorry, can you repeat that?
Would it mess up the function or is it just pointless to do that?
Let's try. Yeah, it gives an error. Yeah,
Okay.
if you have to delete that data set that we had on the chunk at this point, because the pipe is doing that for us. Okay, so I'm going to continue here. I stopped at pivot longer, so I add a pipe, hit return. Pivot longer was soy K5. I can go to the soy K6, just copy the command, come back to the pipe and it all chunk, paste it, delete the data set soy K5 from that separate function. And do the same for the select. So that was soy K7. Add a pipe. Delete soy K6 coming in. Let's see here. Yeah, I think this is actually where I stopped on my code. So if you continued past the select here, so if you also added, oh, I mean, we can do the arrange as well. Arrange is not going to hurt anything. So let's just add it up until the arrange if you're already ahead. And then let's stop here. If you did go beyond the arrange, you can just delete it and make sure you delete the pipe as well. Like if you have a pipe here and you stop there, it's gonna throw you an error because it is expecting, because of the pipe, something else after it. Let's just delete and keep it like this. Okay, so if I just run this, and if you got everything right, so if you got the pipes afterwards, and if you remove the incoming data set from the functions above, it should have run nicely. And now soy KW, which is what I'm calling here, should be exactly the same as soy K8. Right? And there's actually a way that we can check that. So there's this function called identical, and here I have soy K7, but actually you want soy K8. So you can just change that. So if soy K8, which is everything we did up until arrange, is exactly the same result. So every column, every cell of that data is exactly the same as soy KW, which is what we did with the wrangling part. This function identical returns true. So it did return true. So let's say if we try soy K7, which is different from soy KW, we would expect to see false here, returns a false. So I just wanted to show you here that everything we did step by step, one by one, all the way up until soy K8, we can actually just combine all that into a pipe workflow using the pipe right here. So basically our entire class is summarized or resumed, or summarized, I guess the best word, with this. And what I wanted to show you this is because for me, on my workflows, whenever I'm doing things that are sequential like this, I always use the pipe. That is just such, it really changes your mind to the way you think about programming. It makes things a lot easier, I guess.
So say you go and you go through all of this, I guess if you're running it with the pipe, does it show you specifically what point down your error is if you have one?
That's a great question. So let's say here, if I have an error, let's say I say pounds breaker with an S, which this column here, pounds, does not exist, right? So if I run this entire pipe here, it's going to throw me an error. So let's see what happens. Okay, throw me an error. It's saying that the error happened somewhere here. And then if we look here, it says object pounds per acre does not exist, right? But the error happens for the entire pipe because it's all connected. So that is a good point that, so if I'm doing, I do only pipes when things are connected like this and makes sense to go from one to the next. And if something does happen wrong and like, oh, the output is not what I was expecting, what I basically do is I just add a comment, I comment off a pipe at a certain level and run it. Right, so let's say, let me just keep the mistake here, keep the pounds with an S, which we don't have. So let's say I run this and get an error, and then I say, okay, let me troubleshoot it. Let me go pipe by pipe and comment that off and run it, because then it only runs up until before that pipe that I commented off, and I run it, right? So, okay, green, it worked. I remove that, add the comment to the next pipe and run it. Okay, didn't work. So here is one issue. I know there's something going on in this mutate here because it didn't run up until here. So I come and fix. So that's a way that you can troubleshoot a pipe workflow. It's definitely a little bit more difficult as far as if you think of like doing step by step. But once you get the gist of it, is really a lot more efficient.
And when you cut off the pipe, it gives you the same error as like in that line, it tells you the same thing about mutate
Right.
as well. Okay.
Yep. Great questions. Okay, so the last thing, so this is a very typical workflow for any data analysis, regardless if it's geospatial, if it's precision ag or not. So we got raw data, so SoyK processed it to a state that we are happy with, and it's a good state for us to do analysis and plots and so on. So now let's just go ahead and save to file this data set that we created. So I want to use a function called write_CSV. I want to save this as a CSV. The first thing that we give it is the actual object that we're saving to file, which is soykw. And then you can open and close quotation marks because we're going to give it the path. So right now we're in the code folder. You want to do .. / to get outside of the code folder and on the main level of the project. If we hit tab, you're going to see all the other folders. Because this is an output, we can save that in the output folder. And I want to save this as like, give it a name of soybean_processed.csv. So if you run this, if you got your paths, so remember that the one of the cool things of projects is that it helps you to get the paths for both writing or reading data, which is when you're bringing into R, but also for writing data when you're exporting out of R. Projects just really help us making that simple. So if you go in your output now, you're going to see your CSV there. If you click on that CSV, it's going to try to open in R, which is not really nice to see. So what I normally do is I just, so I clicked on that engine and I asked to show folder in new window, which opens on my file system. And then if we double click at that stage, it launches in Excel. But then we can really see like we have our data cleaned, ready for analysis and saved to file. So when we import this data again for analysis, we just already import the data that's ready to go. We don't have to be doing a lot of wrangling again because that step already happened.
So when you do the open to the new source or whatever, you need to save it again, or is it already within the output file and either saved as a
It saved
Excel
it.
file?
Yeah, it's saved. So now that you export it, it's going to be there. So remember that like soykw is just an object, right? I can recreate it if I have the incoming raw data in the code, but soykw by itself is not saved anywhere. We use the write CSV to export it and then actually have a file saved on file that we can then use in future scripts or analysis, right? Okay, so I guess this kind of wraps up my class as far as the exercise that we did in class, but now I have an assignment for you, which I want you to basically, starting from SoyK, so I already made a chunk for you starting with SoyK. I want you to use the data wrangling functions that we used in a pipe workflow. So we're going to be using the pipe to generate the average. So we're going to have to use the mean function, the group by and summarize of KPCT for each potassium rate within each location. So what we did above on the SoyK10 was to summarize over location only. Now I want location and rep. I think that's what I said, right? No, sorry, location and potassium rate treatments, right? So what's going to happen here is for each location, we're going to have another, well, for all the data, we're going to have another column saying potassium rate. And for each location, you're going to have each one of the potassium rates and an average for each location and potassium rate. That's basically averaging over reps, right? Over the blocks. So I wanted you to do that. You can use the chunk that I started below for you to do this. Just as a tip, the final data frame should have 16 rows. If it doesn't, then we're doing something wrong along the way. And also make sure, I'm gonna be very picky here because I want you really to think through all of that I'm asking, right? So I'm asking for you to use the pipe, to do average of KPCT of potassium rate in kilograms per hectare. So remember, soy K does not have kilograms per hectare. You're gonna have to create that, and then group by, summarize, and so on. So that line I gave you was, it's not correct. So I actually, you can turn this back to me by this Friday before class. So Friday, January 27th, 9 a.m. So if you want to change that, this should be, should take you maybe, I don't know, 5-10 minutes. If you got what we did in class, if maybe you have to study more to understand, it may take a little bit longer, but it shouldn't take you a lot of time. Just so you know. So what I want you to do is by this deadline here, I want you to copy and paste the table, the output table that you get from this chunk, which would be something, it's not this, but you can just like copy this and paste. That's what you need to send me by email.
So you said you have on here at 9 p.m. or you mean at 9 a.m. like before class?
Yeah, sorry. Yeah, 9 a.m. right before class. Yeah. And if you have trouble, if you're getting stuck, something's not working, try to go through the class again, the code again. But if it's still not working, let me know. I will definitely help you out and send you in the right direction. But that's what we have. All right. Any questions for me? Here in Athens.
So we need to copy that output in the Excel and send it to directly.
Right, the output that you get. Yeah, I mean, not the Excel, right? So you just copy from the chunk.
And paste
Right.
it in the email.
And paste in the email. Yeah, that's all I need from you. All right. Any questions online? Let me pull up the. Okay, no questions. So you can
Dr.
just,
Bastos, do you hear me?
yes, just a second online. Just let me answer a question here. So what I need from you all is just like on that chunk. So this is not the one I want you to copy and paste, right? Because it's not the assignment, but on the output of the assignment chunk, you just copy this and paste on your email. That, I mean, I think it's going to look okay. If it looks weird, if you want to send me as a CSV, you can also do that. If it looks okay, I've done this in the past and it looked fine on the email. It didn't look like messy. But if it looks messy, you can export it to CSV. You know how to do that already, and send me the CSV if you paste in the email and it looks weird. Yeah, someone online had a question.
Dr. Bastos, when I want to do the last part for write CSV,
Mhm.
there's an error, attempt to use zero length variable name.
Okay, so is it okay if I help you out with that after class?
Yes, sure.
Yeah, because I would need to see your screen,
Thank
and
you.
it's not the best setup here. And I want to give the podium to Dr. Lacerda to continue. So if you can't, so I'll probably have, I think I have some time at 2, if that works for you. But just send me an email and I can help you out to see what's going on there.